Have you ever looked at a chemical name and just thought, wow, that is a completely different language? Well, today we're going to crack the code. And you know what? It's not about memorizing a bunch of random words. It's actually a universal language for scientists, and it follows a surprisingly simple set of rules. Think of it like a puzzle. By the end of this, you'll have all the pieces you need to solve it.
All right, let's just dive right in with a little challenge. Take a look at this molecule. How would you even begin to name this thing? I know, it might look a little intimidating right now, but trust me, in just a few minutes, you're going to be able to name it, no problem at all.
And here's the good news. This whole system is totally logical. There are just a few core rules. No guesswork involved. Once you see the pattern, it all just clicks into place. So, let's get started. Okay, so every single organic compound is built on a skeleton of carbon atoms. That's the backbone. So the first and most important step is always to find the longest continuous chain of carbons and just count them up. This table right here, this is basically our vocabulary list. Each number of carbons in that main chain gives us a specific root name. Think of it like the molecule's first name. So 1 carbon is meth, 2 is F, 3 is prop, and it just goes on from there. So let's see this in action, right? The simplest possible compound has just 1 single carbon atom. That means its name is always going to start with the root meth. Simple as that. And as that chain gets longer, the name just changes right along with it. If we've got a chain with 3 carbons, we just look at our little chart and find the root prop. See? It's a really simple lookup process that gives us the foundation for every single name. Okay, so we've got the root of the name based on how many carbons there are. The next piece of the puzzle tells us how those carbons are actually connected to each other. Are they linked up by single, double, or maybe even triple bonds? Now here are 2 key terms you're going to want to know. If all the bonds between the carbons are single bonds, we call that compound saturated. But if it has at least 1 double or triple bond in there, we call it unsaturated. And that little distinction is absolutely crucial for our next step. So each bond type gets its own special ending or suffix. Saturated compounds, the ones with only single bonds, get the suffix -ane. A double bond gets -ene, and a triple bond gets -ine. So that 3-carbon chain we saw earlier, if it has all single bonds, it's prop-ane. But if it has a double bond, it becomes prop-ene. See how that works? All right, last but not least, we add the part of the name that gives the molecule its unique character. You could even call it its chemical personality. This is all determined by something called its functional group, which is just a specific atom or a group of atoms that decides how the molecule is going to react with other things. Here are a few of the most common ones you'll see. If you spot an OH group attached somewhere, bam, it's an alcohol, and the name's going to end in -al. If you see a carbon double bonded to an oxygen right at the end of a chain, that's an aldehyde, and it ends in -al. Now, if that same COO group is stuck in the middle of the chain, it's a ketone, and it ends in -1. Each group has its own unique suffix that tells you exactly what family the molecule belongs to. So we have all our pieces now, right? We have the root name from the carbon count, the middle part for the bond type, and the ending for the functional group. Let's run a molecule through our little assembly line and see how this all comes together. Let's name this molecule together. First, we count the carbons in the longest chain. We've got 1, 2, 3. That gives us the root prop. Easy. Second, we check the bonds between the carbons. They're all single, so we add -ane. And third, we spot that COO group right in the middle. Hey, that's our ketone. So that gives us the suffix -one. Now you just put it all together. Prop, -ane, -one. Propanone. See? We just built a chemical name from scratch. So as you can see, this isn't some kind of random guesswork. It's actually a really reliable formula that you can use to decode the name of pretty much any simple organic compound you come across. And here it is. This is the master formula, your recipe for success. You start with the chain root, which you get from the number of carbons. Then you add the bond suffix to describe how they're all connected. And you finish it off with a group suffix that identifies the molecule's unique personality. That's it. Okay, so let's go all the way back to that challenge from the beginning. Let's use our formula. It has a chain of 6 carbons, so the root is hex. The bonds between the carbons are all single, so we add -ane. And that functional group at the very end, that's an aldehyde, so the ending is -al. Put it all together. Hexanyl. Hexanol. See? The system works perfectly. So now that you have the formula, what other molecules can you name?